In our previous segment, we have created an in-memory database called FAISS. Then we had taken an OS walk within our workspace. We have extracted the contents from this PDF file using the PyMo PDF loader, that too within our workspace. Then we have extracted the text and then we split it into the chunks. Each chunk is sizing 500 and we created a chunk overlaps in order to preserve the context. Then the same thing has been ingested it into the in-memory database called FAISS. This setup is basically an ephemeral setup. The moment we restart our notebook or if we restart our laptop or server, whatever, we will lose the data. We need to preserve this data for future reference or as and when we need it. For that, the procedure is pretty straightforward. If you look at here, we have some 568 token, all right? So I'm going to save this vector store to our local database. It is as simple. Before that, we need to create, or we can define db underscore name equal to vector database. This is going to be the vector database, and the next option is vector underscore store dot save underscore local, and here we have to define the db name. And let's execute it and see what is happening here. A vector database folder has been created, and if you look at it, here we have a pickle file and here we have an index FAISS, which means whatever our data that has gone to the pickle file and the FAISS database indexes here. So whenever we need to load this database back and we need to run the search parameter. So we are going to perform that task. In this case, I'm going to restart everything. So now if I run this, I'll be getting the error. Nothing is gonna work out, right? Because there is no module, nothing is loaded. So let me restart it once again to clean it up, this errors and all. So for that, I may need to go for clear. Right, that's fine. I'll do one thing. I'll just make a cut, then delete. I'll create a new one because I was supposed to get a code block over here. Anyway, I'll keep it as it is. Now I need to go to one more cell here. Here I'm going to define the database name. In this case, what we should do here is we have to define the full path. For that, I need to copy the path, then I need to mention it. So this is basically our database. And the next part is, I'm just going to, since it is, I'll put it R. The pattern has been declared so that it is assigned to the DB name. Perfect. Now we have to import the FAISS. For that, what we will do, we need this. I'm loading all the modules just to make sure that we are gonna get the necessary FAISS modules, right? Once we came here, we are going to do the vector underscore store equal to FAISS dot load local, and we have to define certain parameter. First thing is DB name that we have already declared it here. Next is going to be the embedding. So embedding we will define here. I'm just executing it. Embedding, then embeddings equal to, or embeddings, that's enough. And next is allow dangerous deserialization is equal to, I can put true to make sure that some HTML text, whether to allow deserialization of the data, which involves loading a pickle file. Pickle files can be modified by malicious actors to deliver a malicious playbook that result in execution of arbitrary code on your machine, because this is something like a security parameters. You might have noticed in Jinja template and all, because when we run the Ansible playbook, if we are using the Jinja template, Ansible won't allow us to iterate over the HTML and all, because that will mark it as what we say undefined, right? Similarly, we are disabling that feature so that we would be able to load the whole vector data from the pickle file. Okay, so we have everything in place now. Let's run it and see how it goes. So vector store has been loaded. Now we are going to do a question. Question is equal to what is agile? Okay, this is my question. So here I am going to ask docs equal to, so here vector store, or I will do one thing. Okay, vector store dot search. I'll use the same query parameter. Query equal to the question, and k is equal to, I'll put 5. Then next parameter search type equal to, I'll put similarity. Okay, then what else? Let's execute it and see what is going to happen. So it has been searched, right? Perfect. Now let's do print docs. If we print this, we are able to see the document ID and the source. Then if we look at it here, we are able to see that title agile practice on some subject keywords, and definitely by end of the file we should be able to see page content. Yes, we are able to see that, right? The page content is the Agile Manifesto, Agile Coach, an individual with the knowledge and experience in Agile who can. So this is basically the search result that we have. We have passed a question into the vector database and we have received a certain a result. Now this result is going to pass it to our LLM, so that this result would be the LLM's context. Also, we will be passing the end user's question to the LLM. So the LLM will do a question framework based on this context. Assume that we have somewhere around 600 pages, or let's say 1,000,000 pages, and we asked a very small question. Our high-speed database provided us a 100 words or 1,000-word answer. That 1,000 word is going to be, along with the question, will be going to the large language model, so that we are making its life pretty easy, rather than gigabytes or terabytes of data to be processed. And of course the large language model's context memory will be choking, and it will land into a catastrophic forgetting or in a hallucination mode, right? Rather than that, we are giving a short and sweet search result. Based on the search result, it will perfectly fine-tune and will provide us a refined and composed response. So that's the basic use case of a vector database, or a retrieved augmented generation. So the question has been raised from the end user, it has gone to the vector database, and it has retrieved the query. Then the query has been passed it to the large language model. There it has done its own enrichment or augmentation. Those augmented data has been generated and put it in our chatbot as a response. That is called retrieved augmented generation. So that's it for now, and we will do the further RAG integration with our large language model in our next video. So if you have any doubts or suggestions, feel free to put it in the comment, and I will try my level best to answer those questions or the use cases. And once again, thank you so much for everyone. So bye for now. Bye bye.